We're going to be talking about hydrates today. These notes are not in your packet, so you can add this to the back of your note packet, the teal colored one. But they are not in there if you're looking for them. The hydrate is a compound that is made of an ionic compound that can absorb water. Okay, a hydrate is a compound, and I'm going to write ionic above this, in which water molecules are attracted and become part of the crystal structure. When we did the flame test lab, you may remember that some of the powders that were in the little boats had kind of become liquidy. That is because they were hydrates and they were attracting water from the air. Hydrates are named according to the rules for ionic compounds, and you use a prefix added to the word hydrate like you use for covalent compounds. For example, here we have copper 2 sulfate. Copper 2 sulfate will attract 5 waters around it. So the name of this compound is copper 2 sulfate pentahydrate. The next one we know is sodium sulfate. And we have 10 waters. The prefix for 10 is deca. So we would have decahydrates. Last one, magnesium sulfate, MgSO4. We use a dot between the water, or the ionic compound in the water. Hepta means 7, so we would have 7 waters. Now, when you calculate molar mass, you have to take into consideration the water. The extra water adds to the compound's molar mass. For example, if we have nickel sulfate, we want to do the molar mass of nickel sulfate, that is hexahydrate. So first we'd have to look up nickel on the periodic table, 58.69. We have 1 sulfur, 32.07, and we have 4 oxygens, which is 64, 16 times 4. And then we have 6 waters. Water, of course, hydrogen, you have 2 hydrogens, so 2.016, and 1 oxygen, 16. And we would multiply that by 6, and that would be what we would add into our molar mass. So we have 18.016 times 6, 108. We're going to add that to the nickel, 59.69, plus the sulfur, 32.07, plus the oxygen, 64. 262.856. One mole. Okay? What if you're given a hydrate and you need to determine how many waters are around that molecule? How will you do that? Well, you remove the water by heating it. When the water is removed, it's called anhydrous, which means without water. So, to figure out how much water is removed, we need to know the mass before we heat it, the mass after we heat it, find that difference. Here, for cobalt 2 chloride, before heating, the cobalt 2 chloride has a mass of 1.62 grams. After heating, it has a mass of 0.88 grams. What is the mass percent of the water? So we're going to need to figure out, first of all, how much water did we lose? 1.62 minus 0.88. We lost 0.74 grams. Oops. Now, So what is the mass percent? Remember that percent means part divided by whole. So the part is going to be 0.74 grams of water. The whole was 1.62 grams. 0.74 divided by 1.62. We get 0.4567. Multiply that by 100. 45.68% was water. Now, what are hydrates? How are hydrates useful? You actually all have dealt with them before. You know the little packages of stuff that you get in your shoes when you buy your shoes? Those are anhydrous substances that you can then, they work to absorb water. So this is kind of the opposite of a hydrate. This is anhydrous, meaning it's going to absorb water. I have a little video to show you of how this works.
Hey guys, Katrina from Ubico here. We've got our sales manager joining us today, Alex Berg. How you going, Alex?
I'm very well, thank you, Katrina. Hi viewers.
Thanks for joining us today.
Very welcome.
So I've roped Alex into having a chat to us about desiccants.
Let's start off with a pretty easy question. Katrina, what do you think desiccant might be?
When I think of desiccants, I guess I'm more associated with the little satchel of like silica gel that I get when I buy a pair of shoes. So just that little packet. Yep. That's how I see it.
Very cool. So on a day-to-day basis, absolutely, we would know desiccant or silica gel in a little pouch that may be about yay big, that's inside a shoe, might be inside a travel bag, in other forms of clothing, just basically to prevent any forms of moisture. But from a packaging perspective, obviously we're talking about bigger products which are designed to capture more moisture and more water and used in a slightly...
This is a desiccant tray that hasn't been used at all, and then after, let's say about a month, it turns to this sort of a slushy liquid, and then the final process is it's just an absolute runny liquid going on in here. So that's pretty different stages that they go through.
There's a bit of a membrane, which is a fabric or a cloth orientation, and what it does, that moisture will seep inside and drop down to the bottom of the tray.
So you saw in that little segment a company that sells desiccants. A desiccant is exactly that. It is something that is hygroscopic. So I'm going to throw that word in there. Okay, and if it attracts the water molecules and holds them so much that it will dissolve, we say it is a desiccant, or deliquescent, sorry, which is what a desiccant is. This is an E. My husband has a storage unit, and one time we were there, it was spring break, and it was really, really humid, and the door had been left open, and I think that the air conditioning system had malfunctioned. So we went and bought these tubs of desiccant and put them in there, and when we opened the lid and took the lid off, they just had all this dry, it looked like kitty litter. Set it in there, and when we came back a week later, they were both full of water. They had absorbed so much water. So we started putting desiccants in things when we put them into storage, like this. Okay, here is another example of something that you will actually get to see in a couple weeks when we do our solutions unit. one of the things that we'll use in our solutions unit is sodium hydroxide. Now, when we use sodium hydroxide, you'll notice if you let it sit out without a lid on it very long, it will start absorbing water. And you'll be able to see it even just in the classroom, the amount of time that you have it out after you've found the mass, and then you use it for the making a solution. You're going to see that it will absorb some water. So that's one thing that we'll have to be very careful of when we do that lab. Make sure that the lid's kept tightly on our sodium hydroxide canisters. Alright, so now you have a worksheet to work on. You've got some definitions. You've got naming. And then it says how many grams of water would be in 1 mole of sodium carbonate. Let's do that together. 1 mole of sodium carbonate, you'd have 22.99 times 2 for your sodium, plus 12.01 for your carbon, plus 3 oxygens is 48, and then 10 hydrogens, or 10 waters. Each water is 18.016, so we would multiply that by 10. Okay. So the total mass would be 286.15. What part of that is due to the water? Well, the part that's due to the water is 180.16 grams per mole. So if you have 1 mole, the amount that is due to the water is 180.16 grams. So 1 mole times 180.16 grams in 1 mole is going to give you 180.16 grams. Okay? Go ahead and work through these, and that's all we're doing. Thank you very much.